What's up? It's still me, and well, it's the break, but is there a break for the great? No, I don't think so. But anyway, for this video, we're gonna discuss addition and subtraction of rational algebraic expressions. Let's just jump right into it. And so for this video, our goal is to recall first addition and subtraction of fractions, and afterwards for us to somewhat remember how can we simplify the answers in lowest term. And of course, the focus will be about addition and subtraction of RAEs with similar and dissimilar denominators. So let's start first with our first goal. So we're still with our dear crewmates for this video, and we're going to continue with them. This time around, we're going to check whether or not the answers of each crewmate are correct or is correct. So the first one we have here is 1 over 7 plus 4 over 7. So we're trying to identify whether the answer of this crewmate is correct or not. Well, basically, since here it's similar fractions, the answer 5 over 7 is actually correct. So that is correct. 1 over 7 plus 4 over 7 is equal to 5 over 7. Next, what if we have 2 over 11 plus 5 over 11? If you add those two fractions, the answer is indeed 7 over 11. So blue is also correct in this part. To follow, what if now we have yellow, and instead of addition, we are dealing with subtraction. So you have here 5 over 9 minus 3 over 9. And is it correct for yellow to say that 2 over 9 is the answer? Well, actually, that's correct also. 5 minus 3 is equal to 2. That's why it's 2 over 9. To follow, is it correct for yellow to say that 2 over 11 minus 5 over 11 is negative 3 over 11? That's actually also correct, because 2 minus 5 is equal to negative 3. And the answer is basically negative 3 over 11. So let's discuss the important detail that we are trying to recall in simplifying, or basically addition and subtraction of similar fractions. The word there is similar. Basically, the idea that we have discussed there will lead us to fully understand how to add or subtract rational algebraic expressions. And we were able to add or subtract similar fractions by simply copying the denominator, because again, the word similar means that the denominators are the same. So we copy the denominator and then we either add or subtract for the numerator. So that concept will play a huge role once we deal with the RAEs. So to continue, let's say now we have our next task. Since we're done recalling addition and subtraction of fractions, let's now add and subtract similar RAEs. So now we have violet, and the concept here is that we want to add A over B and C over B. And again, the denominator is B, they both have it, so we basically copy it, and then we add the numerators A plus C. So in this case, we think that violet is correct, and actually that is true. Again, what happened here is basically we look at the denominators, and if we find out that they are similar or they have the same denominator, we simply copy it and then we apply the operation to the numerators. So A plus C. Because again, you cannot add A and C because they are different variables. They are not like terms. To continue, the next question for violet is this. You have 2 over 3A plus 5 over 3A. Is violet correct to say that the answer is 7 over 6A? Well, unfortunately, violet is incorrect. Why? As you can notice, the important detail that we were trying to pay attention to is that the denominator should be the same for similar fractions. And are we supposed to add them? No. We should simply copy it. So we copy the denominator, which is 3A, and then we add the numerator 2 and 5, so the answer there is 7. So oops, violet is actually an imposter. So we kick out violet because that is wrong. To continue, we now have gray, I think, or black. But basically here, we now have 2x squared all over x plus y plus 5x all over x plus y. And the answer is x times the quantity 2x plus 5 all over x plus y. As you can notice here, there's nothing wrong with the denominator because it's the same, it's similar, we simply copied it. Now look at the numerator. Do you agree that the answer is x times the quantity 2x plus 5? Well, let's discuss it. So, we're given with the given 2x squared all over x plus y plus 5x all over x plus y. And again, we simply copy the denominator as seen on your screens, and then we combine the numerator. Sir, why don't we add 2x squared and 5x? Because they are not like terms. Class, please remember this. We can only say that terms are like terms if they have the same variable and those variables have the same exponents. Indeed, they both have x, but the one that we have at first is 2x squared, and the next one is just 5x. So therefore, we cannot add them. In this case, what do you do once you have combined the terms in one RAE? Because again, it's similar. So there's one denominator now and then one numerator. What you can do here is basically an application of factoring. So please remember that you can apply different kinds of factoring techniques depending on the given. If you look at 2x squared plus 5x, you can see already that both terms have the variable x. So from there, we can say that the GCF is x. So we factor it out. So once you factor out the x, 2x squared divided by x, that's 2x. 5x divided by x, that is equal to 5. So this is correct. And that is our final answer. So therefore, black is actually correct. Again, what happened here, we combine the terms in one RAE. We combine the numerator and then we copy the denominator. And then if we can do factoring, we do factoring. Next, we have this one right here. It's a little longer compared to the first one, but fear not, you don't have to panic. Again, remember the steps. Look at your denominator. Is it the same? Yes. So you copy the denominators, x squared minus 9. So far, black is actually correct. And then now you check out the numerator. You have x squared minus 2x minus 7. And in the second numerator, you have 3x plus 1. Since the operation is addition, all you have to do is to add the terms and combine those that are actually like terms. So let us discuss this item. So once you combine it in one RAE, we're gonna have x squared minus 2x plus 3x minus 7 plus 1 all together. So the next important detail there is you combine like terms. Yes, indeed, you can see there that x squared plus x minus 6 became the new numerator. But how did that happen? Basically, pay attention to the like terms that you have here. You have negative 2x and 3x. They can be combined because, again, they have the same variable and the variables have the same exponent. So negative 2x plus 3x is equal to positive x. While negative 7 plus 1, they are like terms because they are constants. They're whole numbers. So negative 7 plus 1, that's actually equal to negative 6. That's why our new numerator is x squared plus x minus 6 all over x squared minus 9. In this case, what we can do now is apply factoring. The numerator is a general trinomial. So basically, we think of factors of negative 6 that if you multiply, it's negative 6, but if you add, it's positive 1. So we have 3 and 2, and the reason why 3 is positive because the middle term is positive, and the reason why 2 is negative because, again, we want to have factors of negative 6 that if you add, it's equal to positive 1. And below x squared minus 9 is a difference of 2 squares. So the factors of x squared minus 9 is x plus 3 and x minus 3. So we simplify those that we can simplify. Since they both have x plus 3, we can simplify or cancel that out. Our final answer is x minus 2 all over x minus 3. And that's it. So no one is ejected so far, so we'll give them a pass because the answer that was given earlier is partially correct. It's just that the black crewmate wasn't able to factor it completely. So always remember that. So now, how about if it's subtraction? As you can notice, this is similar to the example earlier, but this time around the operation is subtraction. When we're dealing with monomial numerators, it's not a problem. Basically, just like addition, you combine the terms, but the operation is different. Instead of addition, it's minus. So we have 2x squared minus 5x all over x plus y. And again, the GCF is x, so we factor it out, and the final answer is that. So no problem with here so far. But now, what if a we have an example like this wherein the second RAE is a little long with more terms. So you have the first one as x squared plus 3x plus 2 all over x squared minus 2x plus 1 minus 3x plus 3 all over x squared minus 2x plus 1. Basically here, what you need to do first is to be careful with combining them in one RAE. Indeed, they have the same denominator, x squared minus 2x plus 1. But the important thing here is that since this is subtraction, we are not just gonna say it's minus 3x plus 3. No. Instead, the minus sign will be distributed to the numerator of the second RAE. As you can notice in the first line of the solution, it became minus times the quantity 3x plus 3. Again, you're going to distribute that negative sign to the entire numerator of the second RAE. So minus times 3x or negative times 3x is negative 3x. Distribute the negative to positive 3, that's negative 3. So there, basically, you can now combine the like terms. 3x minus 3x, that's 0. 2 minus 3, that's negative 1. So now your numerator is x squared minus 1 all over x squared minus 2x plus 1. Your numerator is a difference of two squares, and then your denominator is a perfect square trinomial. So what's the factors of x squared minus 1? It's x plus 1 and x minus 1. And then for the denominator, it's x minus 1 times x minus 1. Since they both have the x minus 1s, we simply simplify that or cancel that out, and we're left with x plus 1 all over x minus 1. Basically, class, if you have the minus instead of addition, you distribute first the negative sign to the second RAE, and then it follows the same concept. Combine the like terms. And that's basically it. So basically, subtraction is addition of RAEs with an extra step. So be careful with that. And therefore, green is actually correct. And based on this example, again, how were we able to add or subtract similar RAEs? Again, we simply copy the denominator. We combine the terms from the first RAE and the second RAE in terms of the numerator. And then again, if it's subtraction, we distribute the negative sign or the minus sign. If it's addition, just basically combine them in the numerator. And then after that, combine like terms that you can add. Again, like terms are terms of the same variable of the same exponent. For example, again, you can add 2x and 3x, but you cannot add 2x squared and 3x. And again, also, you can add whole numbers like 7 plus 1 and so on and so forth. And then, once you're able to combine the like terms, you can now start factoring if possible. Factor the numerator, factor the denominator. If they have something in common that we can simplify, go do so. And that is it. And now we're actually done with similar RAEs. This time around, we're going to focus with dissimilar RAEs. But again, it's important for us to remember how to deal with dissimilar RAEs. It's also important to deal with, dissimilar fractions. So you have here 1 over 7 plus 3 over 6. So is it correct for blue to say that the answer is 9 over 14? So let's check it out. Basically, the first thing that we need to do here is to get the LCD, and the LCD is 42. So 42 divided by 7, that's 6 times 1, that's 6 over 42. 42 divided by 6, that's 7 times 3, that's 21. So therefore, we have 21 over 42. And in this case, 21 plus 6 is 27. 42, basically copy it now because they are now similar fractions. And then, since they have 3 as a common factor, simplify that. And what's left is 9 over 14. So this is actually correct. To continue, how about if you have 2 over 3 minus 4 over 9? Again, what you need to do first is identify the LCD. The LCD here is 9. So what is 9 divided by 3? That's 3. Times 2, you get 6. What's 9 divided by 9? That's 1. Times 4, that's 4. And since the operation is subtraction, 6 minus 4, that's 2. Then copy the denominator, it's 9. So it's 2 over 9. So basically, when we're dealing with dissimilar fractions, what we need to do first is to get the LCD of the denominators. It's something that you guys should be careful with. As you can notice with our previous two examples, the first one, the LCD is 42 because we got it by simply multiplying 7 and 6. This is a technique for the LCDs if the two numbers or the denominators do not have a common factor other than 1. We simply multiply them. But if you have an example like 3 and 9 as your denominator, since they have a common factor, that will be factored out. Like for example, it could be 3 times 3 is equal to 9. You can write it that way, and it will help you out in factoring properly. To fully understand this technique when it comes to denominators with a common factor, we will deal with it with RAEs altogether. So that's it. Wait, where did that go? Okay, now we're back. So let's say that our first example is this one. It's a little long, I know, and you cannot immediately add x and 2 because again the denominators are different. It's now dissimilar RAEs. So what you need to do first is to identify the LCD. In this case, class, unlike addition and subtraction of similar RAEs, this part you can actually start with factoring. So what should we factor here first? It's actually the denominator. So as we can see, x plus 1 is the denominator of the first RAE, so we simply copy that. So we copy the first one. But in terms of the second RAE, you have x squared plus 4x plus 3 as your denominator. What you can do there is you can factor the denominator itself. So the factors of x squared plus 4x plus 3 is x plus 3 and x plus 1. So once you factor that out, you can now start with identifying the version of it once they are now similar RAEs. So the technique here is to simply identify what to multiply to the numerator. So as you can see, it's x plus 1 for x over x plus 1. And since the LCD is x plus 1 and x plus 3, since they both have x plus 1, divide that. X plus 1 over x, the quantity x plus 1 times the quantity x plus 3 divided by x plus 1 is x plus 3. So you simply multiply that to x. So basically what I'm trying to say here, to put it in a simpler perspective, if they have a common factor now, once you have factored them for the LCD, right? There's a common factor sometimes. So what you do is simply you multiply what they don't have in common. Since the first RAE have x plus 1, the second RAE also have the x plus 1, you simply multiply x plus 3 to the numerator x. So that's what happened here. So now, instead of just x, it's now x times the quantity x plus 3. And since 2 is the numerator of the LCD, there's no problem, just copy it there. And what you do next, distribute x to the quantity. It will become x squared plus 3x plus 2. And once you do that, again, if you can do factoring, do factoring. The factors of x squared plus 3x plus 2 is x plus 2 and x plus 1. Since they both have x plus 1, we can simplify that. So our final answer is x plus 2 over x plus 3. And that's it. So since as you can see here, green got it incorrectly. So we throw lime or green. So we threw that guy out. So now we have pink. Now, the concept here again is in terms of the denominator first. Do they have the same denominator? No. The denominator of the first RAE is 3b. The second one is 3a. So what should be the LCD for that? Is it correct for pink to say that the LCD is 9ab? Actually, that's incorrect because the LCD should be ab. Again, they have a common factor which is 3, so we're good with that. But in terms of the variables, the LCD should be multiplied. So the denominator should be multiplied. A times D, it's AB. And then that's why the LCD is 3AB. And again, since 3AB divided by 3B is A, multiply that to 4a, you get 4a squared. 3ab divided by 3a, the answer is b. So 2b times b is 2b squared. Actually, you can still simplify that. You can factor out the 2 and so on and so forth. So basically, pink is incorrect because of the denominator. Again, if there's a common factor, you cannot multiply the denominators. Unlike if it's like 6 and 7, it's 42. But if it's 3 and 3, the LCD is 3. Okay? That's it. So that's how we add or subtract dissimilar RAEs. That's how simple it could be. So we just gave simple examples for the dissimilar RAEs. We'll have more practice exercises in class. And that's it basically. And that ends the video lesson. I hope that you learned something new. Hope that it'll be retained once you see me in class, or if you're not my student, well, I hope you retain this lesson once you face your teachers during the exams and so on and so forth. Good luck with that. Well, if you want to watch the previous lessons, you could just check them out, all the playlists that I have prepared in this same channel. Be sure to always support, always know what's up, and it's respect. And in case you don't see me, good morning, good afternoon, good evening, and good night.